1, 2, 1, 2. Yeah, this seems to work. Well, welcome everyone. My name is Manuel Egele. I'll be co-presenting with my co-conspirator, William Robertson from Northeastern University. And we'll be talking about, in the next 15 minutes or so, about a system we call Interlock, a system to perform cloud-scale data flow analyses for security and privacy. So, who of you is running a cloud? Great, at least 2 people who should be paying attention now, please. Because it turns out that one of the security issues that frequently occur on clouds are data leaks that are unintended by their customers. Unfortunately, however, if you are a cloud operator, you usually get blamed for that. Because we're at a university, the first example that I dug up is the leaky S3 bucket from an education company, so they got assigned an F, at least by the press. Similarly, if you're running a company called Prestige Software, maybe don't misconfigure your S3 buckets either, because it looks really bad if you can get found out to have privacy-sensitive information out there. And there are many, many, many other examples that I couldn't put on the slide. So this is really a frequent problem, and Interlock, among other things, is designed to prevent exactly this kind of issues. So why would a cloud operator be interested in helping their cloud customers in preventing such security blunders, really? One is economies of scale. Cloud operators are very well familiar with that. If they provide a solution, they can make an outsized impact on the security posture of all their customers. Right? You build the solution once, and you have tens of thousands of customers who can automatically benefit from your solution. So that's great. What do you do with this capability? Well, you can go and then charge your customers for that. So that's one aspect that a cloud operator might actually be interested in by upcharging security solutions. And then another third point, and I should have really made it a little bit smaller here because no one likes to hear about that, is that maybe there is regulation coming down the pipe that will force everyone to do that anyways. Just a snippet from a recent Politico article, it never reads good if it starts out with US officials expressed frustration and then ends with forcing cloud operators to improve or provide better security solutions. Also, SolarWinds, a notorious supply chain attack, gets mentioned here, so it's really a worthy article of your time to read through that. All that said, that's the motivation of what we're trying to do, or prevent rather, with Interlock. And so within our project, we have a set number of goals. So on the one side, we want to provide customers the opportunity to define policies. And we'll see in a little bit some examples about those policies, but really these policies talk about data flows and how data moves through a cloud workload composed of different parts that comprise that workload. At the same time, we want to also give cloud operators, a capability to define policies on themselves. Because clearly cloud customers know the best about their data. There are some policies that cloud operators can also define. We'll see an example about that as well. The way we envision to accomplish this is to integrate support for this new policy language in IDEs. So where developers essentially create their cloud workloads. And then we'll have continuous checking of those policies against the implementation while it's being implemented in the IDE by the developer, as well as pre-deployment by the cloud operator before the application actually gets launched. And then also during the application's launch, the policy will, or during the application's runtime, the policy will continuously being evaluated against what is going on within the workload. Ideally, we'll perform most of these checking statically. Sometimes where we cannot avoid it, we might consider implementing dynamic checks as well as a backstop. If you assume boldly that we will be successful with an approach like this, what will we get from it? Well, on the one hand, we will no longer read the press articles that I used as the motivational example in the very beginning, and potentially we can also stave off some regulatory pressure that at least looks like it's going to be on the horizon. With these high-level goals set, I'll pass it over to Will, who will walk us through an example application.
Okay, so Model set this up pretty well. I want to, quickly step back and say, if you've been paying attention to security and software security in particular at all over the past decades now, data flow analysis is not a new thing. So, why do we, think there are novel challenges here? Well, a lot of this comes down to scale, right? So if you look at this diagram, this is probably not too dissimilar from some of the other talks that we've seen today already on serverless, right? So a modern cloud workload, is not some VM-based monolith, or at least not if you're following best practices, but rather, something that is chopped up into either a container-based workload or, even cloud functions, AWS Lambdas, GCP cloud functions, etc. You might have some state machine, like an AWS step function, that is orchestrating, execution of a succession of these functions according to events. And so we inherently have a distributed application, and this is something that existing data flow analyses, some of which Manuel and I have been responsible for in other domains, like mobile app analysis, are not really well suited for, right? So you have to be able to track flows in and out of multiple components, right? So perhaps from a cloud function into another cloud function attached to the state machine. And another inherent challenge is the fact that you have these data stores with a variety of mechanisms underpinning them. So it's message queues or object storage, buckets, or key value stores that are serve a very central role in establishing flows between different components of your function, so say containers or different lambdas. So there are a lot of challenges here that are not really solved, or certainly not well served by existing data flow frameworks. These are some of the challenges that we want to be able to deal with here. And so part of this, the flip side of all this is that the component-based nature of these cloud workloads actually helps us quite a bit, because the structure of these apps lends itself quite nicely to a sort of modular approach to defining and performing these analyses. So in our vision, we would like to have tooling support to assist the developer using a small set of C annotations to define data flow summaries for each of these constituent modules we're calling. That comprise your application. And so we would be able to tell, for instance, say that one cloud function communicates with others by passing messages or submitting messages to a queue that, like, say, other cloud functions will often, but maybe for this public S3 bucket, we have no flows. And we'd be able to summarize that very succinctly. On top of this, we can then have a cloud operator run verifier that can check the composition of these summaries against either operator specified or ideally customer specified as well policies, so that we can scale, right, using the summaries to the size of workloads that you might have. And this can address not only horizontal scaling, of course, but we were talking this morning about how in the cloud space, it's quite common that you don't have distinct versions, but you have sort of like continuous development. So another inherent challenge that I should bring up is also the fact that these applications change quite a bit. And so, if you start adding more cloud functions, your verification platform has to be able to deal with this, right? And so with this sort of dynamic, changing workload, we need to have a framework that's able to respond to this. So I will turn it back over to Manuel to briefly tell you about some simple policies.
Cool. So with this picture in mind, let's take a quick look at two example policies that we put in here for illustration. One from a customer's perspective and one from an operator's perspective, just to make things a little bit more concrete. So a customer might be running some workload to determine who should get a pay raise. For example, our team should be doing this right. I hope my name is on that list. So what the customer wants to make sure is that whatever data this workflow produces and all the data that gets produced in the intermediary is only accessible to authorized personnel. And so in our proposed policy language, policy might look as follows, given the considerations that the customer knows exactly which data is sensitive. So for example, the customer will know which columns in the database contain sensitive information and label those as sources. The customer also knows what the trusted roles are, so the dean and my department chair. And then the customer also annotates cloud functions the way that Will elaborated, so that the Interlock system can then compute those data flow summaries on top of it. Interlock will compose those summaries, run the policy, and make sure that at the end, if you look at the definitions that we have here for D, T, and U, that salary data can only be processed by functions that release their results to outputs that are accessible by trusted roles. And so essentially by enforcing this policy, Interlock will make sure that no sensitive information is being disclosed to unauthorized parties. Speeding up here in the interest of time, the operator policy obviously has to be a little bit more coarse-grained because an operator policy is global to all customers. So what are the things that an operator might want to prevent? The motivational example that we had in the very beginning is exactly one of those issues. Any data that ever underlies access control should not be shared publicly unless it goes explicitly through a declassification module. And that's another policy, or that's a policy that an operator could set up and then watch for policy violations and correspondingly inform customers before they actually have their data disclosed in public S3 buckets. So with that, moving right on to go into some of the technical aspects of the remainder of the time that we have.
Sure. So yeah, as we've been saying, this is all based off of data flow analysis. This is an extension of some of the previous work that Manuel and I have conducted in other spaces. And so, a very key thing here is, of course, within the language to allow both operators, but primarily customers, to be able to specify sources of sensitive data. And of course, operators can augment this with sort of generic annotations on popular cloud service endpoints. But when they see annotations, we envision tooling support that performs an automated propagation of labels or data throughout individual components of the application. So throughout the cloud function that you're writing in your IDE, for instance. And this, of course, can be integrated not only in the IDE, but also into your CI and CD workflows, such that you generate a policy that travels with the code into the cloud, where it can be verified. So yeah, this just sort of restates some of the stuff that I talked through in the slide, and that Manuel also covered. So there are inherent challenges here in trying to extend and scale data flow analyses that are intended for individual applications to distributed workloads running in the cloud. Thankfully, we can take advantage of some of the structure of these apps in order to make this attractive and solve the problem through composition, right? But regardless of that, there are inherent challenges here that relate to this. Obviously, these are oftentimes heterogeneous applications that are written in a variety of different languages, and so there will be some engineering effort involved to develop tooling that supports not only your standard sort of JVM stack, but also other emerging or also widely adopted languages like Go platform, that nature. In terms of outcomes and deliverables, what we intend to deliver with this project is a few things. So first of all, a novel summary-based cloud-scale data flow analysis engine. Along with that, a policy language, and critically, I think, the developer tooling to support actual use of this language in real applications, which extends to the final point, which is that we are practical security people who want this stuff to be used. And so, as we'll see, a big portion of our projected effort is to not only build these tools, but to test and evaluate them in real environments with the cooperation of industry partners. So, yes, and in terms of impact, right? So I think the argument for both sides in terms of customers and operators is pretty strong, right? So on the customer side, if you are security aware, then you get a lot of benefit here, right? Because you have sort of ready to adopt support for guaranteeing that certain flows that you never want to have happen in your apps simply don't. And if we can't statically guarantee that, then you have dynamic enforcement available from the operator. This also extends to the operator, however, right? As Manuel made a very good case for, you don't want to have these sorts of security incidents popping up in the news. It's simply bad press, whether or not you are responsible for that or not. Your name gets dragged through the mud, right? And so adopting some sort of safety net like this is just a good business move. So, we put together some details on what we think this project might look like. So this is an ambitious effort, so certainly a multi-year project, at least 3 years, along with support for a couple of RAs. And like I said, we see a couple of years of effort to build the tooling to investigate what the policy language would look like, and all of these sort of technical details, but we also envision a good chunk of time and certainly expanded in the last year or so to actually testing this stuff in real environments and real workloads. So this is just a summary of what we're talking about, but at this point, I will stop here and we'd be happy to take any questions.
I'm John Zicke from Online. One of the things that seems that necessary is to get in the way of the workflow or enforce these policies. How do you plan to do that? Had the IDE version of it, but yes.
I'm sorry, I missed the first part. One thing that seems necessary is
that in order to enforce the policies, you have to get in the way of the command flow, the workflow that goes through these functions. How are you planning to do that?
Yeah, that's a great question. I think, there's a couple of ways that you might envision it. So one would be, say, a service mesh, if you're able to do this in treating the flows in terms of the black box, more or less, so just like with endpoints. So like an IST-IO type of framework would be one approach, or container sidecars, for instance. Something else that we were thinking of, and this also sort of extends to if you want to do any sort of dynamic enforcement, is say bytecode rewriting. Of course, this sort of then produces constraints on the technology stacks that you can support. Of course, you can get a very long way through targeting, say, JVM or other stacks. And this is also ameliorated to some degree in that we envision being early in the developer lifecycle or software development lifecycle, I should say. So this is not necessarily something where we need to do some fancy bytecode rewriting or even binary rewriting, God forbid, but we can be in IDE and applying transformations at the source code level, which is something that we have a good deal of experience with. So. Yeah, great question.
Any other questions?
This is Tim Rudolph with the Air Force, and the question is probably a very easy one to answer, but particularly in the press examples noted, the PII or PHI may be made up of small attributes that by themselves are not that. So can the policy and this framework take advantage of looking for the pre-assembly of PHI or PII types of sets of data, and in that way mitigate that issue?
That's an excellent question, and yes, I think it's something that the policy language will have to be able to do. As you observe. It's oftentimes the case that it's not the leakage of a single piece of information, but the aggregation of data that can present risk to customers and downstream populations. Absolutely, yes. Okay, thank you.